Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, we're going to take another fresh and interesting new topic, that is sequence and series. And what we are going to learn first is the concept of sequence. So let's begin. After completing the very lesson today, my dear student will be able to write out more terms in a given sequence. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, your favorite segment of the lesson, that is Mercy's Fun. Today, we will give you another another amazing things in mathematics. That is how you can now test if a number is prime. So I'm going to show you after completing my lesson today, how you can now test and find out if a given number is prime. So don't go away. To begin the lesson, my dear student, let me first explain what is a sequence in mathematics. A sequence is an ordered list of numbers, and those numbers are called the terms of the sequence. And the word order here means there is a criteria for making the list. That is, if we are to look at the list, there is a criteria, there is a condition of making that list of the numbers. So that sequence of numbers, or that list of numbers that has a criteria of making it is called a sequence. Let's just take an example. Example number one of a sequence, we have a sequence of numbers 3, 5, 7, 9, 11, and so on. Look at this the list of numbers. If you look at it critically, there will be a criteria of making this the list. It's not just writing the numbers up here. There is a criteria, and that criteria is what we call the order here. Let me just give you the order of this list. The order, it says, is addition of 2. That is after the very first number, that is the very first term. To get the next, you add 2 to this first term, it will give you the next term. That is 5. When you add the 2 to 5, it will give you 7 the next term. If you add the 2 to 7, it gives you 9 in the next term, like that. So this is the order. This is the criteria of making this list of numbers. That is addition of 2. Let's have another example of sequence. I have 4, 1, minus 2, minus 5, minus 8, and so on. This one also, there is a criteria of making this list. There is a condition that is now followed in writing these numbers. It's not just up here. The order there is nothing but subtraction of 3. When you subtract 3 from 4, it gives you the next term, which is 1. 1 minus 3 gives you the next term, which is minus 2. Minus 2 minus 3 gives you the next term, which is minus 5, and so on. So even if you are asked to write more terms after this minus, it will be able to do so because you understand the criteria. That is the order of making that list. These types of list is what we call the sequence. Another example, you have 1, 2, 4, 8, and 16. This one, there is an order. Also, the order in this make a list is multiplication by 2. 1 times 2 gives you the next term, which is 2. 2 times 2 gives you the next term, which is 4. 4 times 2 gives you the next term, which is 8, and so on. This is another order. Another list we have is 100 minus 24 minus 4 over 5. This one, there is an order also. And let me just give you the order. The order is division by minus 5. When you divide 100 by minus 5, it gives you minus 20. Minus 20 divided by minus 5 gives you positive 4. Positive 4 divided by minus 5 gives you minus 4 over 5, and so on. This is what we call a sequence. So there must be an order. The order may not only be addition like number 1, or subtraction like number 2, or multiplication like number 3, or division like number 4. It may be something else. But it provided there is an order, so it is called a sequence. So let us move. So this is another example of sequence. 3, 5, 8, 12, 17. And let me just give you the order here. I believe it's not of this. It's additional deposition. Add the deposition. That is starting from the very first one, the next term place, the next term. This is number 2, term number 2. When you add 2 to this, 3 gives you 5. This is term number 3. You now add 3 to the previous term, 5, it gives you 8. This is term number 4. So you add the 4 to the previous one, 8, it will give you this. This is term number 5. When you add a 5 to 12, it gives you 17. So this is the order in this case. You can see it's addition, but the addition is not addition of constant number. We are just adding the position of the term. This is still a sequence because there is a criteria. So example here, we are asked to write two more terms of this very sequence. We have just 4 out of these numbers there. We are asked to write more terms of this sequence. Solution to this very problem. So what we do first is to copy the given terms there. That is the numbers in this list. And we are asked to continue making those lists. So we have to look at the numbers there and understand what criteria is used in making this, just the samples of these 4 numbers in the list. So if you have 1, the next term is minus 3, the next is 9, the next is minus 27. So you need to understand what happens between 1 to get to 3, minus 3, I beg your pardon, from minus 3 to get to this 9, from this 9 to get to this minus 27. You can see the numbers somehow are becoming positive and negative. So if you multiply 1 by minus 3, it gives you minus 3. And the minus 3 multiplied by another minus 3 gives you 9. 9 times minus 3 gives you minus 27. So it's like what we are doing here is multiplication by minus 3. That will now be the order. So the order is now any term to get the next term. After it, you now multiply that present term by minus 3. So this is the order. This is the formula. That is to get the next term. N plus 1. What you now do, you take the current term and multiply it by minus 3. So you have Tn times minus 3 will give you the next term. This the Tn plus 1 means the next term. So if I have the very first one, I want to get the term number 2, that is the next term. So I'm now multiply this first term by minus 3. It will give me this. If I want to get a term number 3, so I'm going to use the term number 2 as my Tn. That is the meaning. So let me just write more terms. So the next term after this is minus 27. So I'll now take minus 27 as my Tn. Multiply this minus 27 by minus 3 to give you the next term, which is the Tn plus 1. So there I'm going to multiply minus 27 by minus 3. That will give me positive 81. So next term, I will now multiply 81 by minus 3. That will gives me minus 243. And the next term after this, I'm now going to take minus 243 multiplied by minus 3. That will give me positive 729. So these are the 3 more terms after this minus 27. So let me just move and take another example. Example number 2, it says write the 3 more terms of the sequence. This is the sequence. You have 250, 25, 2.5, 0.25, and so on. Solution to this very problem, copying the given sequence. 250 as the first term, 25 second term, 2.5 third term, and so on. So you need to look at this the few terms given, understand what happened from this 250 to get to 25, from 25 to get 2.5, and from 2.5 to get to 0.25. You look at the terms there critically, understand whatever happened is the same thing happens to get the next term. So looking at this critically, 250 to 25 is division by 10. So let me just write the rule, the order. The order there means to get to the next term, that is Tn plus 1, that is the next term. What you now do is to take the present term divided by 10. So 250 divided by 10 gives you the next. 25 divided by 10 gives you the next. 2.5 divided by 10 gives you the next. So you can now write more after this. So to get the next term, what you now do, you take the 0.25 divided by 10. That will give you 0.025. And to get the next, you also divide the 0.025 to get the next term by 10. That will give you 0.0025. And the next term, because we have to write 3 more terms, so I have to move and write 1 more. So you now divide this also by 10 to get the next term. That will give answer 0.00025. This is how we now answer this very question. Let's just move and take more examples. Example number 3 says write 3 more terms after this 1, 8, 27, and 64. Solution to this very problem. copying the given sequence, and you look at the sequence critically, understand what happens to get this the terms. This is 1. Next is 8. Next is 27. Next is 64. You can see if you think it's addition of 1 and to 7 gives you 8. But is it 7 we added to get 27 on this 8? The answer is no. If you think it's multiplication, 1 times 8 gives you 8. 8 times 8 is not 27. So you have to think again. You have to think again. So it's like what happened? Each number, that is the position. This is position 1, position 2, position 3, position 4, and so on. So it's like you now take each and every position and find it is a cube. Because this 8 is 2 raised to 3, 2 cube. This 8 is 2 cubed. This 27 is 3 cubed. This 64 is 4 cubed. That is the position of any term, just to cube that very position. So the order here is now, that is term at any position, Tn, term at any position. And what you now do, use that very position, raise it to the power of 3. Raise it to the power of 3, just like we have seen. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So next will now be 5 bit cubed. So if I just copy my sequence and write more 3 terms, I will now get the next term. It is position 5. So I'm now going to raise the 5 to the power of 3. Look at it. Next will be 6 to the power of 3. Next will be 7 to the power of 3, because these are the respective positions. So I'll now find the value of 5 raised to 3, 6 raised to 3, and 7 raised to 3. That will give me these terms. That is the next 3 terms. Let me do that. So I'm going to have 5 raised to 3 is 125, 6 raised to 3 is now 216, and 7 raised to 3 gives 343. These are the 3 more terms of this very sequence. Let's just move and take more. Example number 4, it says, given that the nth term of the sequence is given by this formula, that is term at any position, n is given by 5 plus the 2n. So you now substitute n by the position there, and simplify. What you have in the end is the term at that very position. So the question asks is to write first the 3 terms of the sequence. Solution to this very problem: copy the given formula, that is Tn, term at any position, n is equals to 5 plus the 2n. So if I want to get the very first term, I'm now replacing n by 1 there. Let me do that. So T1, that is term at position 1, will now be equals to 5 plus the 2 times n. Instead n, I'll put 1 there. So 2 times 1 gives me 2. And 2 plus 5, in the end, I'm going to have 7. So term number 1 is now going to be 7. So I'll move to get the second term, because the question says write the first 3 terms. So this is the very first term, term number 1. So let me get a term number 2. Term number 2, I will now replace the n by 2 in this very formula. So I'm going to have 5 plus the 2 times 2. 2 times 2 will be 4. So 5 plus 4, that gives you 9. So term number 2 is now going to be 9. So I continue term number 3. I'm now replacing in this formula n by 3. So I'm going to have 5 plus the 2 times 3. 2 times 3 gives you 6. And the 6 plus 5, that gives you 11. So therefore, the very first 3 terms of the sequence will now be 7, 9, and this 11. This is the end of this very lesson, my dear student. I hope you find it resourceable. And let me just move quickly to the last segment, mass span, and explain how you can now test a given number, whether it is a prime or not. So it says for any prime number p, p minus 1 in bracket, and the bracket, the factorial of that very bracket, add 1 to the result. This result, if that number p is prime, must be divisible by the number p itself. Let's just test and see. Example, we now let p to be 7. We all know 7 is a prime number. So I'm now going to have 7 minus 1, which will now be 6. So I'm going to find 6 factorial, add 1 to the result. Let me do that. So I'm going to have 6 factorial plus 1. And the 6 factorial, remember, is 6 times 5 times 4 times 3 times 2 times 1. You can see it in the bracket, then plus 1 outside the bracket. And this multiplication in the bracket, that is the 6 factorial, gives you 720. And 720 plus 1 gives you 721. And I tell you this number 721 will now be divisible by 7. So let's just see whether 721 can be divided by 7. If you use your calculator, 721 divided by 7, it gives you exactly 103 no remainder, which means it's divisible by 7. Let me take another prime number 3. We all know 3 is prime. So let me just find what will now be 3 minus 1 factorial plus 1. Let me do that. So I'm going to write 3 minus 1 factorial plus 1. This gives me 2 factorial plus 1, and 2 factorial gives me 2 times 1. Then that result will now be 2 plus 1, and this gives you 3. I tell you this 3. This is the result of this p minus 1 in bracket factorial plus 1. This is the result. So you can divide this by the prime number that you have used there, which is 3. So 3 is divisible by 3 to get 1 no remainder. So this happens to all prime numbers. So any number that you want to find out whether it is a prime number, just substitute in this very function p minus 1, that number minus 1, find the factorial, then add 1 to the result. If the final result is now divisible by that same number, then of course the number is a prime number. We'll see more of these things in mathematics in our subsequent lessons.